So the process here is going to begin by creating the bee first. And once we have the bee, we're going to put it into a little oven to sort of babysit it, if you will. And how many people here have seen glass making before? Are any of you glass makers? No? Okay. Well, when we work with glass, we have to keep everything hot the entire time, right? If glass cools too quickly on us, it wants to crack, it wants to break. So we have a garage that we're going to be making a lot of use of during this demonstration. And I'm going to talk about what they're doing in just a moment. But just to highlight, this is our garage. And just like you could park a car into a garage, you can park glass into this one. What you can't see from your seats are there's 2 doors on the opposite side here. So right now, this is around 1,000 degrees. And I'll talk a little bit more about the garage and how we utilize it. But we're going to put some components into that garage until we need them to start assembling the final bee goblet. Now, this is a good example right here. Megan brought these 2 in. Isn't this really cool? I love this piece. It's fantastic. So she's going to be working a very similar shape, very similar concept. The bee, I think, is going to be the same colors as what she has here. The stem will be that same green. But she's going to use a different color for the cup and the foot. And we'll talk more about that as we get there. But up here, we have 2 different containers, these little trays that are full of frit, F-R-I-T. We have green and what's this other one? Black. So frit are chips of crushed color glass, and Brad's also going to get some really nice camera shots here as he's working, Brad Patoka down here that will zoom in on the action. So the melting furnace has clear glass inside of it. And when we dip a pipe in, we turn to collect that glass, and it's all clear glass that's inside. So we can add whatever colors we want throughout the process. It's very common to have a furnace full of clear, and then you can add whatever color or colors that you want as you move throughout the piece. So Megan will be sculpting in the body of the bee. What George has is actually a small piece of opal yellow or an opal orange. And Megan's rolled through the black, and this is really fun to watch. They're winding, they're coiling a little bit of that orange glass right around that little black part that Megan started with. A nice even placement, too. That takes a really good sense of hand-eye coordination to do that evenly. So that will become the stripes for the bee. Again, using this as a reference, it's really nice. We've got one that we can actually look at as a model. She's forming the body right now. So then we'll have to make the head. She's got these little eyes that she'll put on there, which are really, really cool. And of course, the wings. And then this bee will be just about done and can go away into the garage. Now, this is a really fantastic view that you're going to get. We have a camera mounted safely behind that oven. It's not actually in the furnace. There's a very small window of specialty glass made of fused silica. Has anybody heard of this? Pure silica has a very, very high melting temperature, well above that. That oven's 2,000 degrees, and you'd have to get it to about 3,500, I think, to really start melting the silica window. So the camera is safely tucked behind that window, shielded by the window from all that heat. But that's our reheating furnace, and you'll see Megan use that throughout the rest of the show. And we have a smaller one over here, too, that George will make use of as he's helping out. So this little segment, she's using a pair of steel blades called jacks, and she's squeezing down into the end of that bit. This is going to be the head, I think. She purposely didn't place the wrap all the way down that little bit of black glass that she had, so she's left some material there just for the head of the bee. You'll see her use those jacks quite a bit. It's my personal favorite glass-making tool. They're the most versatile one, I would say, that we have. And you'd find a pair of these or something like them in every glass studio around the world. So they're steel blades that are about as sharp as a butter knife. They're not very sharp. But the blade, the handle, and then the strap is the head of the tool, and that flux grip right there. Especially when we're making goblets and whatnot, you'll see her use these quite a bit in a variety of ways. As we work with them, as the metal heats up, you might notice some smoke beginning to come off from them, maybe even a little flame from time to time. We put beeswax on here as a lubrication. It's like an oil, right? You could put oil on here and it would work very well too, but at room temperature, the oil would sort of leak all over the place. The wax is great because at room temperature, it's solid and it stays on there until the tool heats up, and then the wax becomes very slick. So we've got a variety of colors. There's 3 different pans that have different frit. George is now rolling through a yellow, a transparent yellow. The frit, we can talk a little bit about that. We buy ours from a company over in Germany called the Reichenbach Company. And they've been around for about 2 centuries now, and they make, I guess, about 200 different colors to work with. There's transparents, opaques, translucents, many different shades and tones of all the colors that you could think of. Does anybody know what glass is made of? What's the main ingredient? Sand, very good. I think I heard silica. Those are both correct. Silica sand is very, very refined. We have some right here in this container. You can see it's pretty fine particulate, kind of like talcum powder. Comes from the Earth's crust. It's a very abundant material in the Earth. We add some soda ash and some limestone. Those three ingredients will give you soda lime glass. That's the most basic type in the world. It's what we're melting in our furnace. Does anybody know what you add to make colors? I'll give you a hint. This blue that we see in the bottle is called copper blue because you add what to make it? Copper, exactly, copper oxide. So different metal oxides, chlorides will form different colors. Cobalt makes a very rich dark blue. Copper makes that lighter teal blue. Iron oxide would make the green. The black that she's working with, it's probably mostly manganese, which would make a nice purple. And there's not really a true black colored glass. If you stretch black glass very, very far or too thin, it will eventually look purple. So it's just a very, very condensed purple. But our melting furnace, Lucas is dipping in now. He's getting a little bit of glass. This is a very large ceramic pot we call the crucible. And it'll hold 1,000 pounds when it's totally full. If we fill it right up to the brim, there's probably 800 pounds in there to work with right now. And it runs nonstop, 2100 Fahrenheit. It's a very specific temperature. It's actually at 2120 Fahrenheit because the viscosity of the glass at that temperature is just like table honey, room temperature table honey. If we turn that oven up to say 2200 Fahrenheit, it would be a little bit more like olive oil in consistency, and it'd be very difficult to get any of it out, right, on the end of a blowpipe or a rod. And if it's not warm enough, then it's too viscous and it's very hard to gather. So Brad's getting a really good shot. Now you can see the doors on the garage. So there's two of them, and he's placing the bee into the garage, and that just keeps it safe. So I'm going to talk a little bit more about this as they start up the next component. You can see over here we have the piping that's coming in. So this is our natural gas, comes into a burner. And this side is much, much hotter because the burner's on that side. It makes sense, right? But it's heating the whole thing. Over here we have our pyrometer, thermometer, and it's running at about 1,000 degrees right here. So when we put something into the garage, we want it to stay warm without it distorting. So if we put the bee right in front of the flame, where it's probably 1,600 Fahrenheit, what do you think would happen to the bee? In about 5 minutes, it would flatten right out, right? We'd have a little puddle of what was a bee. So we can put the pieces into usually around here to over here, which we call this the colder side, and that's a deceiving term. It just means that the glass isn't going to soften until we're ready for it. And then we can shuffle it over to the hot side for just a few moments to give it a quick little blast of heat before we pull it out at room temperature and start to use it. The concept there is that before you bring something from the garage, you want to make sure that you have a little extra heat into it because air temperature is quite cold to it and it can shock the glass. So you use the garage in that way. You put them on the colder side, and then when you're ready to pull those objects out, you shuffle them to the warmer side for just a few moments, and then you bring them out. Does that make sense? Okay. Again, this soda lime glass, it's very prone to thermal shock. So if it cools too quickly below 900, that's really the safe temperature line for this type of glass. If it cools too quickly below that, it's going to crack, or it wants to crack. When we're done with this piece and everything that you see up here, we put them through a slow cooling process called annealing. And the annealing for this will take about 8 hours to slowly cool. And we'll talk more about that. So Megan is now beginning what will be the cup for the goblet. And traditionally, goblets are made in 3 parts. We have the cup or the bowl top, the stem, and then the foot. So she's now working on the cup top, and we're going to put the cup top into the garage as well. And then she'll make the stem and the foot, and we'll begin to assemble everything. There's quite a bit of planning that goes into making a piece of glass, especially something as complex as this. Now, Megan has done this process many times. Megan has been on 3 different ships many, many different times. Celebrity Cruise Lines is part of Royal Caribbean. And about 10 years ago, Celebrity approached our museum, and we partnered up with them to create a hot glass show at sea. So there's 3 vessels in the Solstice class fleet that have a hot glass show, a studio, and are staffed with 3 different glass makers to do demonstrations every day or night all around the world where these ships sail. It's absolutely amazing, the program. It's been going for about a decade now. But Megan has blown glass on all those vessels. She's been all over the world. So she's going to set up a color fade, I think. She's got a little piece of color bar. I've showed you the frit. I'm going to show you a chunk of rod or color bar. pull out a couple examples here. So this, essentially, if you took this and slammed it with a hammer, kept beating on it, you'd break it up into tiny chips, and we could call that frit. And then you could put it into a tray and roll molten glass through it, and it would heat it down. And you can see this is yellow, right? Very obvious. What about that? What color does that look like? Looks black, right? This is a really nice light teal blue. It's just so dense right now that one small piece of this can be stretched very far, and then it turns into the true color. So this, you have to preheat a little bit differently. If I took a piece of this and I put it into that furnace at 2,000 degrees, this would explode from that same thermal shock. It's too large, so you have to soak some temperature into it before you really begin to heat it and melt it down. And she prepped these pieces before she started. So Megan, you said fuchsia and aurora? Yellowish aurora, two really nice colors, both transparent, jewel tones. So she cut little pieces of those off and put them into an oven over here that heats them to just about 1,000 degrees. And remember, that the 900 degree mark, that was what I was talking about 1,000 degrees. That's a safe point for this too, the color bar. And the color fade, she doesn't have it in this one. I don't know if we have a piece up here that shows a color fade, but she's stacked two of those pieces on top of each other. And she'll form a bubble inside this, and when she blows it up, one side of the cup, the bottom side, will have that color, and then as it works its way to the top, we'll have the other color, so they'll sort of blend together. Of course, everything, when it's hot, looks orange, right? That's the heat from the glass, the infrared light that it's emitting at such a high temperature. So it's really hard to tell what we have, but she knows because she prepped these. And the blowpipe that she's working with here, this is a stainless steel tube. We have a variety of these up here. I'll show you one of the larger ones that we have out on the floor right now. Now, this is also a good point to talk a little bit about scale. So we know what we're going to create, we know what size piece we're going to create, and we know what pipe we need to work with. If you wanted to make something very light and delicate, this pipe would be terrible because this is a heavier gauge pipe. It's very heavy to hold on to, but it's great for having a lot of extra glass on it. So if you want to make something really big, you wouldn't want to work with a pipe that she has because it's very small. But that's what we call a cup pipe, and it's perfect for working smaller scale. So you pick the right tools for the right job. But here she goes, dipping into the furnace. This is called gathering. She turns very smoothly in one direction. That's the gathering process. And again, if you think of getting a big bowl of honey, dipping a chopstick or a pencil into it to collect that honey on the end, it's the same kind of sensitivity that it takes in the turning with our hands and our fingers. And I'm just going to show you because it's really quite deceiving when you watch Megan. She's very skilled at doing this. But for beginners, this is one of the hardest things to do, is to get glass out of the oven and not have it get out of control like that. Because if you stop turning for a split second, the glass really wants to just drip to the floor. 2,100 degrees. So we use those wooden scoops called blocks. They come in lots of different sizes. You can see this is one of our larger ones. These are great for shaping molten glass and centering. We want to evenly distribute that glass on the end of the blowpipe. If you have a nice even shape and it's heated evenly throughout it, once she starts to inflate, that bubble will inflate evenly, and that's really important, especially when you're making a thin goblet. The fruit woods that we use for those tools are great, like cherry, apple, peach, pear. They burn slowly. They burn away very clean, leaving no residue if you don't overuse them. And they hold water for a while too, so 3 good attributes. So here she's actually forming a bubble. She just pressurized the blowpipe. She got a nice heat on everything. She blew pretty hard into the mouthpiece of the pipe and quickly capped her thumb over the end. That creates air pressure. And it does take a bit of pressure to puncture through where the glass meets the blowpipe. There's a seal of more rigid glass that's formed right there. But once you have a bubble established, it's very easy to inflate at this point because the glass is very, very soft when it's hot. When it's this hot, I should say. So this is a pretty basic tool. It's called a marver, just a steel table. She can shape the glass. She can cool the glass too. The metal acts as a heat sink. It draws heat out of the material. Sometimes we're doing that intentionally. And she's going to apply this pattern now. So let's talk a little bit about this. It's called a diamond facet texture. It's one of my favorite textures to create. And there's a special mold that we're going to use to create that. You can see a larger one down here too. It's got a series of diamond-shaped teeth lining it. This one probably has 1,000 teeth on the inside. The one she's going to drop into is a smaller one. but just as tricky to use. They're very, very difficult molds to learn how to work with because of the texture to create the print on the bubble can grab the glass and not let it go once you go into the mold if you use it improperly. So it's all about getting the right setup, and that means the right shape and the right temperature in the glass to go into the mold, but most importantly to come out of the mold as well. Well, like I said, she's practiced this many times. She's used this mold many, many times. She'll make the whole thing look easy. It's a really nice setup, sort of eyeballing the mold. These molds are made from bronze. You can see a variety of the other ones down here are made from aluminum. These are optic molds, straight optic molds that put a ridge pattern in that you can see in some of the vessels. That vase over there has that fluted texture to it. So once she goes into the mold and creates this pattern, she's going to inflate the bubble to the volume that she's looking for pretty fast. When you use any of these molds to apply texture, it's important that you work efficiently, because if you have to overheat after you apply the texture, what happens to the texture? It starts to soften, right? It starts to melt away. So she gets a really good heat on it before going into the mold. She'll jump up on the box, lines it up, squeezes in there nicely. You can tell she had a perfect dimension to fit into the mold. You don't want to be too big or too small. You can see that mold does grab, but she gets it right out of there. Nice job. And probably take a quick reheat. This is where you'll see her use the jacks quite a bit. Again, those steel blades, I'm going to give them just a little bit of heat for her. This tool works pretty good when it's been preheated. A little extra wax. Yep. And the very important thing, one of the very important things at this stage, is not just to shape the bubble as it's inflating, but you'll see her use the tool overhand and start to squeeze down into the glass. And she's going to create a constriction line with those blades. Right here. It's much like a crease. We need to give ourselves a place to easily break the bubble free from the pipe when the time comes. And the tighter, more concise she gets that line, the sharper that line is, the easier this piece will snap free when the time comes. It'll break free, and the less likelihood that we'll damage the integrity of the bubble in doing so. So it's a lot like a Kit Kat bar or Hershey chocolate bar. You have those little grooves, you can snap pieces off very, very easily. Same is true for the glass, because glass is very unpredictable when you break it, right? If you just took a hammer and smashed a window, it's gonna shatter, right? Many, many different pieces. Never wants to break in one clean line, so we have to tell it where we want it to break and how we want it to break. And we do so with those constrictions. You'll see her reiterate that line too. And getting some inflation from Lucas, I don't know if you guys can hear, she'll say blow, blow light, stop, blow a little harder. All these commands are very important. If Lucas was to blow too hard, that bubble would expand very easily. And if you blow too thin, it's really hard to go back from that. You can always inflate it a little bit further, but if you go too thin too early, then it can be problematic. That fuchsia is really a beautiful color. So let's use this as an example. This is exactly the format that she's going to create, just a slightly different color. So we've got the cup top, and you notice there's this little paddy, this kind of pad of glass that's in between the actual green stem and the cup itself. She's going to create that right now. So George is going to bring her over some glass. And she's got two different ways she could apply it. We could spool it on from the side, or she can drip it on using gravity. But it looks like she's going to spool it on from the side. And this makes use of the fluidity in the glass to what we call casting off. So she goes through this little roundabout motion with the bit, and she'll drop the rod down with those tweezers, and it pulls the glass so thin, and that little turn at the end just snaps the glass free from the rod that George has. Some cases you'll see us cut glass with the shears, and we have a variety of those to help us do so, but we can cast the glass free like that method. And that gives us a place to attach our handle. So we need to create a handle called a punty to attach to that little paddy so we can now hold on to this bubble from the other side. The blowpipe has been the handle up until now. So to work on the opening, we need to flip the orientation around 180 degrees. And this is a very traditional process in glass making. All these pieces down here, these blown items, we start off on the blowpipe, and then we flip the piece around 180 degrees, and we end up with an opening that we can heat, soften, and shape. The punty has to be brought very, very specifically. George is taking a little bit of glass and he's shaping it on our marber, and he's also getting it to the right temperature. If you attach the punty too hot, it wants to fuse to whatever you stick it to. And that's not good. Well, we want it to stick, but we don't want it to fuse permanently because it needs to break free in the end. So a lot of that has to do with the right temperature between these two connections. So she's lining it up, making sure that the punty's on center. And we can tell if it is by looking at George as he rolls back and forth. The punty is moving left and right, but it's not going up and down, right? So we can see that everything is perfectly in line with the blowpipe. That's good. Here's where she's creating a little bit of extra stress on that constriction, and a small tap sends a vibration through to break it free. Nicely done. That's a very hard thing for beginners. Now, everything in glassblowing is hard for beginners, but that process in particular is the most harrowing, I would say, because you really have to understand the heat very, very well, and most importantly, the timing that goes in with it. And the thinner something gets, the smaller that window of timing and temperature becomes. So working thin is very challenging. But right at that moment, she used a diamond-bladed file, which scores the glass, and it also creates a little bit of cold shock, because you touch that constriction with a cold metal tool, and it shocks it right there, thermally shocks it. And if you do it right, then it doesn't break the whole object, it just breaks free exactly as she's done. But this gives us the opening. She'll soak some temperature into the glass, some workable heat into it, and that's very evident now with that brilliant orange glow. The light has returned to it. You can really see the versatility of those jacks, right? And the jacks come in multiple sizes as well. What she's working with are the smallest pair that we have out here because she's working very small scale. But you can see, you know, there's two sizes that I have over on this bench, the larger pair and the smaller or more medium size. If you were working something very small, you wouldn't want to use the large ones because these suck the heat. They draw the heat out of the glass quickly and it gives you less time to shape. But if you're working a larger piece and you need a lot more leverage, then you would want a larger pair. And there's a variety of tool makers, too. In the amphitheater, we have many different tool makers represented. We've got some from Japan, some from Murano, some from Seattle, some from California. We have tools from all over the place. Just like the bee that got put into the garage, that's on hold right now, once she's happy with the shape of the cup, we're going to put this into the garage as well. And then she'll work on the stem, the foot, and then things get really exciting when we start to add everything together and really build the final goblet. Do you guys have any questions? All right. Well, Megan is from Ohio. I think she was just talking with Amanda about that, but she's been here in Corning for quite some time. She's worked with the museum for many, many years, but I know she's been here in Corning for a couple years now, full time. Our amphitheater, this has been running for a little more than 2 years now. What we're in right now, this used to be the Steuben factory. Is anybody familiar with Steuben glass? Okay, so the Steuben factory shut down several years ago, and when it did, our museum had plans drawn up to expand. And we expanded, we call it our North Wing expansion, the amphitheater hot shop, as well as the contemporary design gallery that many of you probably walked through to come in here. We built those at the same time. It took about 3.5 years of construction in total once they broke ground to complete it and open it to the public. So I still consider this a brand new shop. It's a phenomenal shop to work out of. I've heard many other glassmakers come through here say the same thing. We've had visiting artists from all over the world come in and work with us here, as well as our core staff on a daily basis. So here's where you want that punty connection to fail. And to help it along, she's going to shock it. She's going to stress it by putting a little bit of water onto the punty, only the punty. If you let water drip onto the cup, it would crack the cup. So just another little tap. And it breaks free, just like that. Perfect. And George is very careful. He doesn't want to tip that shovel that he's on, but he's going to quickly walk this into the garage. Because right now it's losing heat. And if he takes too long, what happens? Cracks, right? So he actually had that little shovel, that scoop, preheated. He had it resting in the garage, so we know that it was 1,000 degrees. Because if it was a room temperature and you put the cup on it, it would shock the cup. So we always have to be really careful with any tools that we're using, especially when you're working thin glass like this. All right, so she's ready for the stem. She's got some green frit out here for it, and again, it's the same color as the one that we have there. This would come from iron oxide or rust, which makes green one of the cheaper colors that we have to work with. Now, gold chloride is used to make the most expensive color, or one of the most expensive colors, and that's ruby. And the fuchsia that she's working with probably has some gold in it as well. So ruby glass compared to green glass is about twice the cost. And you can see that frit sticks right away. That's from the heat. So those little chips, they have the consistency of granulated sugar. So as she rolls through, those chips heat up instantly, and that's what causes the frit to stick. And we can roll through that 2, 3, 4 times, but each application, the color is getting denser and denser. So she might roll through that one more time, but I bet no more than 2 coats on there. And this time, she's going to use another optic mold. So I talked a little bit about these. I'll lift this one up so you guys can see. This is a medium-sized optic mold, this ridge pattern. There's a smaller one that she's got set up over by the furnace, and that one's made from brass as well, or bronze, excuse me. And that one I think has maybe 16 points in there, maybe 18 points, a much smaller shape. And the line pattern is a little shallower on the one that she's going to use, but it's going to produce that texture that she's looking for. And she's also going to use another tool before she gets to it. I'll show you guys. The leaf crimp. I don't know if you can see from your seats right there. These are 2 paddles that on the interior of the paddles have a leaf pattern. So she'll use this when she puts the bits onto the stem. She can squeeze it with this, and it'll pick up that leaf print, that texture. Now, I was watching her earlier make one of these, and she twisted the stem a little bit before she started to shape it and contour. And that's what she's doing here, using a pair of shears. So if she's only turning one direction forward at the bench while she grabs, that's twisting it around itself, and it's creating that spiral effect. Those diamond shears that she's using are very, very useful. Not only to cut glass, but you can see to grab a hold of something too. They crimp the glass, they grab it, and they cut. So there's a nice little twist to it. And this is where things get very interesting. Traditional glass blowing, like the cup top that she made, she worked it on center. So always turning, keeping the bubble as straight and even as possible. But creating sculpture like this and beginning to work offset, it makes things a little bit more challenging, I think, because as you turn, you don't have that even weight distribution anymore. It starts to throw things off as you turn a little bit. But she will keep turning this, because if you just stop at this point, it slumps and then it's unusable. But here's a larger pair of diamond shears. Now, there's no diamonds in the material. These are steel. The diamond refers to the aperture that the blades come together at and cut or terminate. And these ones are really nice too, because they've got this little groove, this notch that's bored out in the tips, so you can grab the end of a rod with that as well. So you don't grab the rod, dull the blade with it. But you can crimp, you can grab a hold of the glass, and you can cut with those. Well, we also have straight shears, a variety of those. You might see her use those at some point here. Now, this is another little bit, very similar to the pad that she put on the cup. And this is going to be a pad that we're going to use to attach a bubble for a foot. And the type of foot that she's going to create is called a blown foot. And this is a very Venetian technique. So if I use this as an example, this is a nice goblet. I think Dane made this one. It's a beautiful cup. And again, remember the 3 main components to stemware: the cup top, the stem, and then the foot. So when this one was made, if you forget about the cup for a second, think about the stem. We have this teardrop-shaped bubble. We added this little spool bit on here, which is called Novolio, and then you tip the pipe up in the air. Somebody brings a hot bubble of glass over, a teardrop-shaped bubble, and using gravity, you'll let that bubble sort of drip and make contact onto the center point of the stem. You cut it free, and then you go through a series of steps to turn it into this. And you're going to witness that here in just a moment, but just a little uptake on the next procedure. And that brings George into play. He's got another blowpipe. He's going to dip it into the furnace, collect some glass, and he'll set up that blown foot. You rely on your assistants quite a bit when you work glass. That being said, we always have one person in charge. It's like the conductor to an orchestra. And we use the term gaffer. It's a term that we like to apply. And it's actually an old term. It was derived from a word for grandfather, because in older glass studios or factories, traditionally speaking, centuries ago, when you would learn glass, you would apprentice. And more often than not, you would apprentice with your family. It would be a family business. So the senior most member of the team, the one in charge, was usually the grandfather. So gaffer is a term that has evolved from that. And we apply it to this day for whoever is in charge, the lead glassmaker. But George is working on the foot over here. You can see Brad's getting a really nice shot of what's happening. George does the same method to start the bubble. He shaped it, and he blew and capped air pressure into the pipe. Bubble pops out. He can inflate this a little bit more. You're going to see him use those jacks to start squeezing into the bubble and forming the neck to it, or the tail section of this bubble. This is very important because when you drop the bubble on, you want a nice bulbous shaped bubble to make contact with the stem, but you want a very skinny section to the bubble to easily cut through. So that's the purpose of using the jacks and squeezing down that tail or that neck that he's forming right here. And this is a very time and temperature sensitive approach as well. You're going to see Megan is sort of watching George, gauging when he's going to be ready, and she's just keeping her stem the perfect temperature. Not too hot, because otherwise it would bend and distort, but not too cold either, otherwise it could crack. So she's taking her last quick reheat. She's going to grab a pair of straight shears now. Stands her pipe straight up in the air. George gets a good heat on this. And this is a great posture to see in glassmaking. This really shows the team dynamic and how well tuned you have to be to work together. A lot of people tell us when they watch us working, it's a lot like a dance. And I think it really is. It's a one-shot deal. As soon as she makes contact with that, she's committed to having the bubble stick and stay where it lands. So really lining it up carefully, getting it on center, and she'll take a quick heat. So at this point, it looks more like an onion bulb shape. We have to break the tip of that bubble free to produce the opening. She's going to form another constriction. I talked about how glass makers really get good at breaking the glass where we want it to break, just the way we want it to. Well, you have to be very good at doing that, and mostly through creating these constrictions that she'll form. First thing, she grabs the tip with the tweezers, and she's pulling it, straightening it. It's elongating it slightly, but it's more about straightening the bubble. And then getting right on with those jack blades and squeezing down a constriction. She's sectioning off, too. So if she wanted to make the foot smaller than what she has there, she would section off more of the material as scrap. And the tip of that will just get knocked off here eventually. Again, that's just a diamond-bladed file, just industrial diamonds. It's actually from an old bandsaw. And a little tap. There we go. Nice job. Did you see how Megan was holding the tool on the bubble while George was tapping it? So holding a tool right there, clamping that constriction, is absorbing a lot of the shock that he's sending as he's hitting the end of the bubble. If you don't do that, chances are that shock goes through the entire thing and it breaks the stem completely. So you hold that tool there purposely to absorb the worst part of that shock and just to break the tip of the bubble free. This is where it gets pretty challenging. When she's heating and turning, the way that stem is set, that sort of corkscrew motion, it makes it a little more tricky to turn evenly and open that shape up evenly. But this is where her skill and her experience comes into play. And beginning to flare that open wider and wider. Nice work. Do you notice what she did there too? Can you see the very edge of the foot? Do you notice anything about it? It's got a little double thickness band that goes around the edge. This one has it too. A lot of goblet makers or people that create goblets, these feet are very thin, which is nice. You add a little bit of glass, but you can get a wide surface area so the goblet is stable. But to help increase the durability of the foot, especially when you go to set it down, if you create that double band, we call it a fold, then it just increases the chance of the foot surviving a heavier set down. It's a very tricky little move. She took the jacks and she sort of pushed the lip in very slightly before she went all the way on the inside and lifted up. And that creates that fold. It's a tricky little move. It's very subtle, but it's very, very tricky to do properly. And then she goes in and opens it all the way up. Nice work. So Lucas is there with a dry wooden board. At this point, with a thin bubble like that, you wouldn't want to use a wet board. When we're shaping molten glass with those wooden scoops, it's important that they are wet. But when you're working the glass at this temperature range, it's good to have the wood dry because the water can actually shock it very, very quickly and crack that foot. So a dry wooden board is better. So we're at the point now where, do you punty this now, Megan, or do you put the leaves on first? Okay. So she'll put the leaves on. This is where she'll use that leaf crimp that I was showing you when she gets everything straight. Now, I didn't mention it, but earlier on when she was making the stem, she also crimped a little section right next to the head of that punty that she's working with. So she's given herself a break-off line for that stem. But you have to be really careful when you move back and forth from the bench rail to the rollers every time to set that rod down very, very gently. Remember, vibration is what causes the pieces to break free. Tapping on the rod. And we're counting on that when the time comes. But she's going to be really careful to not let it happen before. To match the color of the stem, Lucas is rolling some glass through that green fret. And she just said 1 coat of that color is fine. It is a pretty dense green. And we have 2 of these furnaces going right now, these reheating ovens. These are empty. They're just big barrels. And there's 2 burners in each one of these firing natural gas and forced air into the ovens. The one that Megan's working out of right now is about 2,100 degrees. We can turn it up or down, depends on what we're working on. Some people want that oven to be hotter. Some people want it to be not so hot. There's a thermostat and a very easy controller just to turn it up or down. And we turn them off at night. We don't need to have them running when we're not using them. Okay, so here we go. First leaf. Cutting glass is very, very easy when it's this temperature. There's very little resistance when you use those shears. Same with that tool, the crimps. When she squeezed that bit right there, that bit of glass was so hot, so soft, that if you took a piece of silly putty or clay, very soft clay, and you squeezed it, that's the same kind of resistance. But the more you tool the glass, the more you touch it or tool it or squeeze it with any of these, especially the metal tools, you're chilling it faster. So there's a working time to the material, and the clock is always ticking when we're away from the heat. We have a great program here at the studio, which is located across the parking lot, called the Make Your Own Glass. Did anybody go there today? Nobody? You can sign up to make a flower, an ornament. You can do a little sculpture. You can do a lot of different things, too. You don't have to work with hot glass if you don't like the heat. But I think one of the neatest things is to watch somebody making a flower. Because at first, you have the glass, it's very hot and soft, and you're using a pair of tweezers or pinchers to sort of pinch and pull a little disc of glass and create the petals. And at first, it's very hot and soft. And as you continue to work it, even seconds later, it starts to really turn rigid and solid pretty fast on you. So much of this is muscle memory. When you watch these guys working, as Megan's turning the glass, turning the pipe, using the tools, her hands are just doing what they need to do. She's not really thinking about how the hands have to move on the pipe anymore. And that takes a few years to develop that. It's a lot like learning to play an instrument very well, if anybody is a musician. So George is creating our punty. This will be the final punty. So this handle that he's making right now, when we attach it to the foot, this is going to hold on to the foot and the stem while we apply the cup top and then while we apply the B. But he's done a similar thing as what they did for the cup punty. Shapes it up on the marver, that metal table, gets it to just the right temperature and shape. And Megan has her stem at the right temperature. It's now completely rigid, around 1,000 degrees. They attach the punty on center. And that's the gaffer that attaches it. When we bring a punty like that, George is remaining very loose-handed. He just gets it in proximity. Megan grabs a hold of it with the end of those tweezers and places it where she needs it. This time, a little bit of water placed on there and a slight tap breaks it free. Nicely done. Very nice. And you notice that as soon as we break free from the one pipe or one punty to another, the first thing the person that gets the glass does is goes right up to the heat, right? Because that's a critical moment. And if you wait too long, the temperature drops, and that's when the stem can crack, the foot can crack. So you got to get right back up to the heat. Waste no time. You can see a little bit of that red glow has come back into the stem after that little reheat. And that's a good sign. The stem isn't really moving right now, but that slight orange tint that's in it is sort of a safety blanket, if you will, because that tells us there's enough heat and it's not in danger of cracking. Especially the foot. It might be hard to see from back there, but that clear foot has still sort of a yellowish tint to it, which is the heat, and that again is a nice little safety net. If that foot ever started to look like ice, basically no color to it, completely crystal clear, that's when you're getting into the trouble zone where the glass is going to get too cold on you and crack. Do you guys need me to jump in for anything? You all good? Okay. So George has the cup top on that same paddle, and he's now shuffling it over to the warmer side of the garage. This is a great shot that Brad's getting. So George is taking it from the colder side, and he's now moved it over to the warmer side. And he's not going to stay there for too long. Again, if he stayed there too long, then the cup would start to soften and bend and distort. And you don't want that to happen. That's a great shot right there, Brad. You can see the burner right there. So George is very, very close to the burner. Getting a little bit of heat onto the cup. And Megan's using an oxygen gas torch. She can adjust the dials on that. The flame right now is probably about 2,000 degrees, I would guess, but we can crank that up to above 3,000 if we need to. And that liquefies the surface of the glass almost instantly. You can see it, just very good concentrated stream of heat. So she's using that to heat up the very tip of the stem right where she wants the cup to attach. If she heated in the furnace, she could heat up the stem in the furnace, but the whole stem would start to bend around, and you really don't want that to happen. I gotcha. You want 2 small ones? Got it. Okay, so here we go. George has got that at just the right temperature. And straight up and down. Again, that's a one-shot deal. She aims for center. Gets good contact. And then gets right into the reheating furnace. And notice how delicately she goes in and sets the rod down, because adding the cup just doubled up the weight of that object. And that punty connection that we're attached to, remember, that's meant to be very delicate, so it will break free in the end. But as soon as you add that extension on the end, it really increases the leverage that's working against the punty, so you want to be very, very delicate when you're moving around with it now. So we're almost done. We just need to add the bee. Remember, the bee was the first thing we made. It's the last thing that will go on. So George is getting that ready now. And for the bee, we're going to use what we call a glue bit. So we're going to use a little bit of that clear glass in our furnace as an adhesion. And that's what she's talking with Lucas right now. So George will bring the bee over on a paddle, but Lucas will be in charge of bringing a little gather of glass at the right moment. And you can see Megan is taking a very quick, very brief series of reheats. We call this flash heating. You don't want to overheat right now, because if you take too long of a heat, the stem starts to bend and things get a little squirrely on you. But these very quick reheats are just to maintain that baseline temperature in every part of this goblet. And this really comes with experience. The timing involved with doing this, knowing how to do it, how long to heat for, how long you can stay away from the heat. Okay, so George has the bee on the paddle. The first thing he does when he comes out with that object is go straight away into our furnace, into that reheating oven. Very important. See, Megan is just heating up her tweezers right there. You want me to blast those for you? Okay, yep. Tips are hot. So she's going to grab the bee with those tweezers, and we just preheated them because, again, if you grab that 1,000-degree bee with cold metal, it can crack it. Beautiful. What do you guys think? Very nice. Yeah. So we are not done yet. Remember, the final step is to slowly cool this, but before we can even do that, we have to get this off from the punty in one piece. Goblets are very, very challenging, and at this point, we really want to make sure that the weakest point in this entire object is the connection to that punty rod. So she's managed the temperatures this whole time just right and has all those connections between the stem and the cup and the foot and the stem, the bee and everything. If she's got all of those at the right points, then this should break free. And George is ready with a pair of forks over here. I'm going to come over and grab the door on the annealer. The annealing cycle for something like this is going to take about 8 hours. It starts at 900 Fahrenheit and will slowly make its way to room temperature. These ovens are programmed to come down on a very specific cycle. So it doesn't cool the piece, it just prolongs the cooling. So the team's getting everything ready. Lucas has put a dry paddle on the bench. Looks like Megan will knock this cup off onto the paddle. First, she's going to put a little water in the punty. So this is where you want to be really careful not to let water touch the foot, because again, one drop can crack the foot. She drops the punty down and the cup up so the water falls away from it. It's a smart move. Just a little bit of water and just another little tap. She's actually using a butter knife to tap around that connection. And it breaks right off. And George will get it into the oven. Yeah, big round of applause for these guys. That is Megan Mathie, George Kennard, and Lucas Milanic. Beautiful work. Whew. It's always such a relief when those come off and get into that oven, and then you can take a look at it tomorrow. How about another big round of applause?